Hi, this is Dusty Jones trying to give you some help on figuring out how to prove some of these exercises. I've got exercise 75 from chapter 5, also exercise 91 from chapter 5 in functions basic concepts. So with exercise 75, I first want to look at the proof in C where it says suppose f is a function from a to b and g is a function from b to c. We want to show that g of f is 1 to, if g of f is 1 to 1, then the function f is 1 to 1. So first, the idea for a proof, if we want to prove that f is 1 to 1, we need to pick two values, I'll call them a1 and a2, in this set A, the domain of f. If it's true that f of a of 1 is equal to f of a of 2, we need to show that a1 indeed equals a2. That's what it means for f to be 1 to 1. So the first step we do is to choose any a1 and a2 in A. And then if f of a1 is equal to f of a2, those exist in B, and that if they're equal, they represent the same element in B. Therefore, since they're the same element in B, then they map to the same element in C through the function g, so that g of f of a1 is equal to g of f of a2. This is by virtue of g being a function. For every input, there's exactly one output. So since the inputs f of a1 and f of a2 are the same, their outputs are also the same, which is why I have this as equal. Now g of f of a1 is really g of f of a1. Similarly, g of f of a2 is g of f of a2. And since we know g of f is 1 to 1, that's what we were given up here, if g of f is 1 to 1, that means for every two values a1 and a2 in the domain of g of f, where g of f of a1 is equal to g of f of a2, we do have a1 is equal to a2. That's exactly what I wanted to prove. And so therefore, a1 equals a2 and f is 1 to 1. The next proof I want to do is D. And for D, it asks us to show that suppose f maps a to b and g maps b to c. We want to show that if g of f is onto, then g is onto. So the idea behind this proof would be to pick any c in C, the codomain of B, and show that there is a codomain of G, and show that there's an element in the domain of B that maps to it so that g of b equals c. That's what it means to be onto. Every element in the codomain is mapped to by some element in the domain. So first, let's choose any element in the codomain of G. And then I'm going to use this fact that g of f is onto. Since g of f is onto, that means for every c in the codomain of g of f, there is this element in the domain of g of f, which is a, and I'll call it a star. There's an a star so that g of f of a star is equal to c. Since g of f is onto, that means everything in C comes from something in A through this composition g of f. So for any C that you choose, there's a particular A star. Now I want to choose B star that's in the domain of B, domain of G. B is that domain. And I want to choose B star so that B star is what we get if you take f of A star. So through this map, A star lives in A, f of A star is in B, and I'm going to call f of A star B star. And we know that that should be a B star. We know that B star is in B because f is a function. So now, g of B star equals g of f of A. That's because B star is equal to f of A. And G of f of A star is, another way to write it, G of f of A star. G of f of A star, we already said, was C. So now I've got this long chain of equalities that says G of B star equals C. Therefore, for any C, we can find a value in B, like B star, so that G of B star equals C, and therefore G is onto. For the next proof I'd like to look at is F. And F says, suppose that F maps A to B and G maps B to C. Show that if a couple of things. If G of F is onto, and if G is 1 to 1, then we get F is onto. So essentially we're trying to prove that F is onto. To prove something is onto, we need to pick any element in the codomain of F, which is B, and show that we can get that element of B from some element of the domain of F, which is A. So that's what I've got here in my idea for the proof. We'll pick any B in the codomain, capital B, and show that there is an element A in the domain of F such that F of A equals B. And that will mean it was that will show it was onto. So first I'll choose any B in the codomain of F, capital B. Now we know that G is a function, and so there's a C star in C where G of B equals C. So that little b that we chose is also in the domain of G. That means it's going to map to some specific element over here in C, because it's a function, because G is a function. We know that G of F is onto, we have that up here in the premise of the proof. Since G of F is onto, that means for any C in the codomain of G of F, over here, which is C, then there is some element in the domain of G of F, and that's the A, so there's some A star in A, such that G of F of A star is equal to C. So I want to choose the A star in A so that G of F of A star gives me this C star that we had up there. So we picked a B in the codomain of F. It also happens to be the domain of G. So that means there's a specific C, I'll call it C star, in that codomain of G. And then C star, because G of F is onto, C star comes from a particular A star in A. So now I'm going to use the transitive property of equality. I have G of B equals C star, and I have G of F of A star equals C star. So both of those equal C star. So I'll say G of F of A star equals G of B. And G of F of A star, another way to write it is G of F of A star. And finally, since G is 1 to 1, we have that up here in our premise. Since G is 1 to 1, if we have G of some input equals G of a different input, 1 to 1 means that those two inputs are the same. So F of A star equals B. Since F of A star equals B, we get F is onto. We started with any element in the codomain of F, and we showed that it comes from an element in the domain of F. So we have the mapping F, the function F is onto. Next, I'd like to look at G. G says, suppose that F maps A to B and G maps B to C. We want to show that G of F, if G of F is 1 to 1 and the range of F is B, then G is 1 to 1. Since we're trying to show that G is 1 to 1, I'm going to pick two elements in the domain of G, B1 and B2, and say if G of B1 is equal to G of B2, I want to prove that B1 equals B2. So first we'll choose any B1 and B2 in B, the domain of G. Now the range of F is B. That's another way of saying that F is onto. The range of F is all the elements that get mapped from A through F into B. And if the range of F is the entirety of B, then F is onto. So F is onto means that there exist these A values, A1 and A2, where F of A1 is equal to B1 and F of A2 is equal to B2. So now we'll suppose that G of B1 equals G of B2. We'll say we've got these elements that are in B, and what if their values after mapping through G are the same? I'm trying to prove that B1 equals B2. By substitution, instead of G of B1, I could say G of F of A1. Instead of G of B2, I could say that's equal to G of F of A2. And using notation, G of F of A1 becomes G composed with F of A1 equals G composed with F of A2. Now we know that this G composed with F is 1-to-1. That was given to us up in the beginning. So that means since G of F is 1-to-1, if we have A1 and A2 in the domain A, where G of F of A1 equals G of F of A2, then A1 is equal to A2. So therefore we have A1 is equal to A2 because we had G of F of A1 is equal to G of F of A2, and G of F, that composition is 1-to-1, so A1 equals A2. If A1 equals A2, because F is a function, F of A1 is equal to F of A2. Finally, since F of A1 is equal to F of A2, F of A1 was B1, and F of A2 was B2. So F of A1 equals F of A2 means B1 equals B2, and therefore G is 1-to-1.